Okay, guys, I've had several questions over test A and test B about percentage yield. So let's talk about percent yield. Basically, percentage yield is a measure of how well did I do when I was in lab. For example, I'm trying to produce copper chloride. If I do math on paper will tell me this is how much I started with, this is the mass that I started with at the beginning of my reaction, and at the end, this is what I should make. Okay, so if I'm in lab and I'm going to do a reaction before I ever do it, I take the mass that I'm supposed to start with, and on paper now, using stoichiometry math, I work out how much copper chloride am I supposed to produce. Right, so on paper, math on paper is supposed to be perfect setting in lab. No human error, no mistakes. I did a perfect job. This is what I was supposed to get. But in lab, when you are actually doing it hands-on, one, it's not a perfect setting. It is real world. You are a human. You're going to have error. You're going to make mistakes. Okay? So when you are doing it in lab, you are getting what's called an actual yield. This is what I actually got. This is what I was supposed to get. And this is the formula to calculate how well did I do. Percentage means the same thing in lab as it does on a test or quiz. How well did you do on that quiz or test? What percentage did you get right? So if you got a 93 on a test, that means that you got 93% of the test questions correct. This is the same thing. I'm in lab. What did I actually get when I did this experiment in lab? Versus theoretical yield. What was I supposed to get? What did I get when I did the math before I ever started? So your actual yield comes from production in lab. And in a problem, it will say the actual yield was blah, 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 blah. Or it will say you produced 25 grams of this. When it uses that word produced means you actually did it in lab. You're actually doing it. That gives you your actual yield. Theoretical means you're probably going to have to calculate your theoretical given the information in your problem using mass, or moles to mass, and a balanced equation. So your theoretical yield may be given to you in the problem, but more than likely you're going to have to calculate it via mass problems first. And then you just plug those in and you're dividing. The actual divided by theoretical times 100 will give you your percentage. So remember, your actual yield comes from production and it's given to you in the problem, right? You're not actually going to be in the lab during your EOC working it out, hands-on. They're going to give you the actual yield in the problem. The theoretical says, in theory, this is what I was supposed to get. So you're probably going to be calculating that, what you're supposed to get. This number should always be less than this number. You are never going to get what you're supposed to. You will always get less. Remember human error in lab, than you're going to get doing the math, what you're supposed to get. Right? So you just plug those numbers in, divide, multiply by 100. That will give you your percentage yield. Okay? If you look on your test, I had lots of questions about one of these. So I'm going to work one out. Number 47 on page 85 on Chemistry Practice Test A. All right, so you are given a balanced equation there, and it says in the reaction below, 64 grams of calcium carbide is reacted with excess H2O, and it produces 57.4 grams. of calcium hydroxide. These are the 2 pieces of information you're given, plus the balanced equation. This is your given amount. This is what you had to start with. When you see that word produces, produces is telling you this is what I actually got. I worked it out in lab, and this is what I actually got, and this is my product. So what you have to do is take your given amount and do a mass to this product. And that will tell you, in theory, if I have this to start with, this is how much I'm supposed to end up with. So let's do that really quick. 64 grams of CaC2 right? Here's my mass set up. Right? This is what I'm given, so my given amount goes on the bottom in 2 places. Here and here. What I'm trying to get to, which is my product, that it tells me what to go to in the problem, CaOH2, goes here and here. Remember, given amount goes on the bottom in 2 places. What I'm trying to get to goes on the top in 2 places. So now I'm going to plug in numbers, and just to refresh your memory where stuff comes from. This number is the mass of 1 calcium and 2 carbons from the periodic table. And that number is 64.1, or just 64. That's the mass of this I calculated. 1 calcium, 2 carbons, added up. This is your mole ratio step, and mole ratio comes from the coefficients. So I look back in my problem. The coefficient for CaC2 is 1. The coefficient in the balanced equation for CaOH2 is 1. Easy step. Now the mass of calcium hydroxide, this is the mass of, I'm going to add it up. 1 calcium, 2 oxygens, and 2 hydrogens. I add all that up, and I get 74 grams. So now when I work this out, multiply across the top, multiply across the bottom, divide, my answer is 74 grams of CaOH2. What is that telling me? This is telling me my theoretical yield. This is telling me, in theory, in a perfect world, if I start with this, this is how much I should produce. But the problem also told me I actually got 57.4. I was supposed to get 74. I only got 57.4. So the next step is to use this formula and plug in. My actual yield comes from my problem. My theoretical yield comes from the math I did. When I divide that out and multiply by 100, right, this number goes in first, 57.4 divided by 74, equal sign, times 100, I get 77.6%. So that's telling me this is how correct I was. I was about 78% correct, right? I only got 57.4 grams when I actually did it. I was supposed to get 74, okay? And that's a percentage yield problem. Ask me questions tomorrow in class if you have any.